Hey guys, this is Mr. Lowry here. I wanted to give you some help on this triangle congruence proofs assignment, just in case you're getting stuck, because I know sometimes these congruence proofs can be tricky, or proofs in general can be tricky. So let's kind of go through where we can find the answers to these problems, and then I'll add a couple more examples from your homework that might help you, okay? So the first piece of information here, this is an side angle congruence postulate. You can find this on page 207 in your textbook, and you're just going to write it down. I talked about it in the first lesson video for this lesson, so you can kind of go through that video if you need it, but it's in the book for you. Okay. The second piece of information is called the third angle theorem, and this is actually a couple sections back on page 186. The proof of this we did in the lesson video as well, the lesson that went for this assignment, or that went before this assignment. So it has to do with using the triangle sum theorem and some substitution and subtraction properties of equality. So this is in the video, this whole thing. You should have got that in class, but if you want, you can go back, because all the videos I posted in Canvas. Okay, this next one here, the angle side congruence theorem, this is actually on page 208, and I already wrote it for you, so you don't have to write it down. The proof of this, you can actually find it two places. It's in the video, again, that first video from the lesson that went with this assignment, but also the whole proof itself is on page 208, and it's a very short proof. It's only 3 lines, but it uses this theorem, which is why we needed to prove it first. So once you have this one's like 3 lines. Okay, so those we talked about in the video, and you should have those down on this already. Okay, the next 2 problems are like example problems that I made up, and those are in the second video. So you may not have gotten that far in your class, depending on how long it took you to do the other stuff. But these 2 example proofs are both in the second lesson video that I made. So if you haven't gotten these down here, you can just open up that video and copy them down. They take a few minutes each. Okay, so that's 4 and 5. This was supposed to be done in class in the lesson, but if you ran out of time, which is okay, they're there for you in the video. Okay, you can watch those. So ideally, if the lesson went as planned, you should have gotten 1 through 5 in class, or basically I did those for you. I wanted to give you a chance to think about them first, but then you have those proofs. Okay, so that should leave you 6, 7, 8, 9, and 10. So there's 5 proofs for you to do on your own. Okay, now what I'm going to do is I'm going to do a few of these with you, just to get you kind of even more of a head start in case you're getting stuck, because I know it sounded like some people, or maybe a couple people, I got a couple emails saying they're a little bit confused. So let's take a look at number 6. Now again, this is actually just going to come from the book, so I'm going to jump over to page 204. Okay, we'll take a look at this figure, and then we'll copy it down. Okay, so this is the one we're after. Okay, we start with congruent triangles, MRN, which is this little guy on the side, and then QRP, which is this other little guy on the side. And we also have this angle right here. MNP is congruent to QPN, so these marked red angles. What we're going to try to show is that the big triangle, the longer triangle, is congruent to this longer triangle. Okay, the ones that kind of overlap. All right, so let's go ahead and copy that down, and we'll get going here. So we kind of have this overlapping triangle shape here. So we'll do kind of the bottom, and I'll make something that goes up like this, like this. This won't be perfect, but it'll be good enough. All right. So something like that. That's kind of funky, but you get the idea. We know that this angle is congruent to this angle. Okay, that's given. We also know that this triangle is congruent to this triangle. That's given. And of course, my picture is a little off, but that's okay. Okay, so let's label the points. M, N, we got an R in the middle. We got P over here, and then we got Q here. Okay. So given, we know that triangle MRN, that's one of these shaded ones, is congruent to triangle QRP. Okay. We also have the piece of information that angle MNP is congruent to angle QPN. Okay, so that's all the given. What we're trying to prove is that the longer triangle, triangle MNP, I think that they call it, yep, MNP is congruent to triangle QPN. Okay, so that's all the information that we have given to start with. Okay, now if we want to show that two triangles are congruent, there's a few ways to do that. Okay, we have basically 4 ways to do that, so I'm just going to list them out here. We can do angle, side, angle, 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 side. We could do side, angle, side, and we can do side, side, side. Okay, now keep in mind that we're given there's an angle here, so that's kind of where we're going to go. All right, so let's set up our 2 columns. Now, if you wanted to do a paragraph proof or a flow proof, you could do that as well. I'm just going to kind of stick to the 2 column. So statements, reasons. Okay, we're going to start with the given, obviously. So triangle MRN is congruent to triangle QRP. And we also got angle MNP is congruent to, angle MNP is congruent to angle QPN, and that's all given. Okay, so if you think about the triangle that we're after here, we're looking for this guy, right? This long guy congruent to this long guy. They already have an angle in common, right? We already have an A. Also notice that they both share the bottom here. This guy is part of both triangles. It's the bottom of this triangle and this triangle. Okay, so probably where I'd go next, doesn't have to be the second step, but you know, doesn't really matter the order. We're going to say that NP is congruent to PN. Right? This thing is congruent to itself. Okay, whenever we're saying that something's congruent to itself, we're talking about the reflexive property of congruence. So I'm going to do reflexive prop of congruence. Okay, so if you think about it, we're pretty much almost there, right? We have an angle and a side. All we need is one more side, and then we'll have side, angle, side. So we're actually shooting for this guy, side, angle, side. We basically are almost there. All we have to do is we have to figure out a way to say that this side is congruent to this side, and then we're pretty much there. But if you think about it, we already know that this triangle, the shaded one, is congruent to this triangle, right? If 2 triangles are congruent, that means we have 3 angles congruent to 3 other angles and 3 sides congruent to 3 other sides. So if these 2 triangles are congruent to each other, then we know already that MN is congruent to QP, because basically what we're talking about is CP-CTC. Corresponding parts of congruent triangles are congruent. So step 3 here, we're going to say that segment MN is congruent to segment QP. Okay, now the reason we can say that, again, is corresponding parts of congruent triangles are congruent. Okay, let's just kind of draw this off to the side here, and we'll give you an idea here. So I'm going to try to redraw this guy. This is going to get a little bit crowded, which is why I'm kind of reproducing the drawing. Ah, shucks, that's not a very good one. Okay. Okay, we got this guy, and then we got this guy. Okay, so let's say that this triangle here and this triangle here we know are congruent. That's what we started with, right? Well, if they're congruent, then this angle has to be congruent to this angle, because the triangles are congruent, right? And this angle has to be congruent to this angle, right? And then this side has to be congruent to this side, and this side has to be congruent to this side, and this side has to be congruent to this side, right? And then we have this one other angle in the bottom here as well. These guys have to be congruent to each other. So by saying 2 triangles are congruent, you basically have all the sides and all the angles congruent to something else to begin with. Okay, let me give you another example with different triangles. Okay, if I knew these triangles are congruent, then I know that these angles have to be congruent, and I know that these sides have to be congruent, and I know that these sides have to be congruent, these sides have to be congruent, and these angles have to be congruent, right? And these angles have to be congruent. Okay, so the definition of congruent triangles basically says that if two triangles are congruent, then you have three angles congruent to three angles and three sides congruent to three sides. That's the definition of congruent triangles. Okay, we use this abbreviation, CPCTC, as an abbreviation for that definition, and it stands for corresponding parts of congruent triangles are congruent. Okay, so the corresponding parts, these two angles, are congruent to each other because the triangles are congruent. Okay, so that's kind of what we're doing here, right? We have these shaded triangles. We started with the shaded triangles congruent to each other, and that means that the corresponding parts of those triangles have to be congruent to each other, right? So that's kind of how we get that third side. So I'm going to say this guy is congruent to this guy, okay? Now we already had from the reflexive property that this is congruent to itself, right? And we started out with this angle. So now we're switching our focus to the bigger triangles, and we have SAS, right? We have the reflexive side, we have the angles that were given to us at the beginning, and then we have these sides that we got from the shaded triangles being congruent to each other. Okay, so now we can finish up. Triangle MNP is congruent to triangle QPN, SAS. Okay, so it's really only a 4-line proof, but you have to kind of understand how to use the CPCTC thing, the corresponding parts of congruent triangles are congruent. It goes back to the definition of congruent triangles, and that is on page 192. So the bottom of page 192 is kind of what you need there. Now I went over this in the previous video, the two example problems that I did for you. I kind of talked about how this works, but for your reference, it's the bottom of page 192. Okay, CPCTC. All right. Okay, let's do a couple more here. All right. If you already have, one of these proofs down, or you kind of got the idea, you can just kind of skip ahead. I'm going to do the next two, and then kind of leave the rest of them for you. All right. So the next one, we're supposed to do problem 6 on page 210. So let's take a look and see what that looks like. Okay. On 210, you have a shape that looks like this. I'm going to see if I can do it a little bit better of a drawing this time. Okay, and then we'll connect this guy here. All right, so this is the shape I have more or less. Again, not perfect, okay? I have this marked congruent and this marked congruent in the figure that they give me. I got the corners labeled, or the vertices labeled. Okay. The other piece of information that's important here is the word bisects. So let's actually just go ahead and start with our thing here. Since we're going to write the given anyway, we might as well write it in the proof. Okay. So what we have here is that QS, that segment, bisects angle RST. Okay. That word bisects is a key word. It means cut in half. So here's QS, right? And it bisects RST, which tells us that these two angles have to be congruent to each other, because bisects means cut in half, okay? So we have that. Now the other thing that they gave us is angle R is congruent to angle T, okay? And all that was given, okay? So that's where we're starting. Now what we're trying to do, our goal, is to show that the top triangle is congruent to the bottom triangle. And once again, we have some options, right? We have ASA, AAS, SAS, SSS. Those are our choices. Okay. We already have a couple angles, so that's kind of where we're going to go. We just talked about this angle being congruent to this angle, so let's actually put that in the proof. That's what, it comes from this idea of bisect, but we still have to state it. So we can say that angle RSQ, this little guy here, is congruent to TSQ. Okay, and we know that because of the definition of angle bisector. Right? Bisect means cut in half. So we already talked about that. We just have to write it out. Okay, so now we have that guy. All right. think about what else we have now. We have this side, right? This side is part of both triangles, just like this guy, right? They shared this bottom. These guys are kind of back-to-back sharing this side. And so what we know is that QS is congruent to QS, right? Or SQ is congruent to SQ. Okay, whenever we say that a segment or an angle is congruent to itself, that's the reflexive property of congruence. All right, so take a look at what we got here. We got angle, angle, side. So we have enough information. We basically have everything we need to show that triangle QRS is congruent to triangle QTS. And what we're going to use is that angle, angle, side, right? Angle, angle, side. All right, so another 4-line proof. Not too bad. You just got to be able to understand what bisect is telling you, getting those congruent things, and you got to use the reflexive property. Okay. That one actually doesn't use CP/CTC, so you could actually probably do that one pretty easy on your own. Okay. Let's take a look at the next guy. So now we're on page 211. Okay, we're going to copy the figure. This is for number 11, and go from there. Okay, so again, do my best to make a reasonable representation. So we have something like that, kind of a long side, and then we have a kind of a short guy, and then we got here, and we got here. Okay, cool, something like that. We have these labeled as 1 and 2. We have this guy V, this is T, this is S, this is Q. We got R in the middle here, and we got these are marked congruent to each other already, and then these are marked congruent to each other. Okay, let's go ahead and set up our 2-column. Again, you're welcome to do this in a different format if you're more comfortable with flow or paragraph or whatever, as long as you make sure that each statement that you write is justified. Okay, so the given that they have, we marked it already, but we know that angle V is congruent to angle S, and we also know that segment TV is congruent to segment QS. Okay, so that's given. All right, now our goal here is a little bit different. Our goal is to prove that VR is congruent to SR. So here's VR, right, and here's SR. Our final goal is to show that these two segments are congruent, right? Okay, here's how we're going to do that. If we can prove that these two triangles are congruent, then that means that every side of the triangle has a corresponding congruent side. So if we can start by showing these triangles are congruent, then obviously these segments will have to be congruent to each other, right? And these segments will have to be congruent to each other. And this angle will have to be congruent to this angle, and so on. So that idea that we talked about, CP/CTC, is what we're going to need to use here. The corresponding parts of congruent triangles are congruent. So again, if I want to show VR is congruent to SR, I got to start by showing the two triangles are congruent, and then the CP/CTC gives me all the rest of the pieces. Okay, so in order to prove the triangles are congruent, the minimum information I need is SSS, SAS, AAS, or ASA. Okay, so let's take a look at what we have. We already have a side. We already have an angle. All we need is another angle. We'll take a look at 1 and 2. Okay, 1 and 2 are vertical angles, right? So angle 1 is congruent to angle 2. Vertical angles theorem. Okay, that wasn't too bad, right? So now we have congruent triangles, right? We can say that triangle, it doesn't really matter which order we go in. Let's say just TRV. Triangle TRV is congruent to triangle QRS. Okay, and how do we know that? Well, we have angle, angle, side. If these guys are congruent to each other, which we just said they were because they're vertical angles, then we have angle, angle, side, angle, angle, side. All right, so now I know that this whole triangle is congruent to this whole triangle. Okay, But remember, congruent triangles, there's 6 pieces of information. That's the definition of congruent triangles. If 2 triangles are congruent, then you have 3 sides congruent to 3 sides and 3 angles congruent to 3 angles. So we start out with a minimum amount of information, AAS, and then all of a sudden, once we prove those triangles congruent, we get all the other pieces. Okay, so the last step here, now that we've shown these triangles are congruent, is to say that VR is congruent to SR, right? Because these are corresponding parts of these 2 congruent triangles. We've already proved the triangles are congruent, therefore these sides have to be congruent to each other. Okay, so CPCTC, corresponding parts of congruent triangles are congruent. All right, so that's kind of how you use this guy right here. Okay, now if you look at the other 2 that you're going to do, which is 14 and 16 on the same page, we're going to use the same strategy. Okay, so here's 14. Notice our goal is to prove that YZ, this guy, is congruent to EZ. Okay, I can do that as long as I show that 2 triangles are congruent. Okay, if I can show that these 2 triangles are congruent, then I can use CPCTC. Okay, same thing here on 16. I'm trying to show that LN is congruent to DB. Okay, all I have to do to get that is show that these 2 triangles are congruent. Okay, if I can show that the top and bottom triangles are congruent, then of course LN has to be congruent to DB because they're corresponding parts of triangles that we know are congruent. Okay, CPCTC. So just for fun, because I think we're on a roll here, let's do one more, and then I'll leave the very last one for you. Now will have to be the only one that you have to think about yourself. And if you get it wrong, no worries. As long as you try, do your best, use your reasoning, write it out, you'll get credit on this assignment. We just don't want to leave anything blank or skip anything. Okay, so it's all about, giving it your best effort here. All right, so let's look at this next one. So it's number 9 on your worksheet, but in your book it's number 14. So we got like a parallelogram kind of idea. Okay. Let's see if I can make these kind of parallel. Not too bad. Okay, so we have something like that. I know it's not perfect, but close enough. Okay, it's also got this X through it. Okay. And we have these marked parallel. Okay, super important. So when you see those guys marked parallel, you probably should be thinking alternate interior angles. Okay. And then we got the vertices kind of labeled with our letters here. Okay. Go ahead and put our table. Statements, reasons, and what they give us is the parallel, which we already kind of marked, and they also give us this midpoint idea. Okay, so Z is midpoint. I'm going to use MP for midpoint, so an abbreviation of CT. Okay, we also know that YZ is parallel to TE. Sorry, not YZ. CY, excuse me. CY is parallel to TE. So that's these guys. CY, TE. Okay, all that's given. We don't have to do any work for that. Okay, now our goal, what it says in the book here, is we're supposed to show that YZ is congruent to EZ. So we want to show these 2 guys are congruent. Okay, now remember our goal for that is to start with congruent triangles. If I can show these 2 triangles are congruent, then of course these are going to be congruent to each other because they're corresponding parts. All right, we can also use these 2 triangles, but I don't think we're going to need those, but we'll kind of see how it goes. All right, so let's label what we got. So midpoint, right? Z is the midpoint of CT. Okay, so what that tells us is this guy is congruent to this guy. Midpoint means right in the middle, cuts it in half. Okay, so what we can say here is that TZ is congruent to CZ. Okay, and and that's the definition of midpoint. Okay, or sometimes like some books will call that the midpoint theorem, but it's the same kind of idea. All right, cool. So we got that. Okay, let's talk about the other piece of information. So we've used this piece of information. Let's talk about the parallel. Okay, so if I have parallel lines and I have transversals here, then I'm going to get some alternate interior angles. Okay, so we have this guy congruent to this guy, okay, because of alternate interior angles. So that could, potentially help us here. Those are kind of about these triangles. But we also have another set because we have another transversal. So we also know that this angle right here is going to be congruent to this angle right here. Okay. So we can, we have angle, side for these two triangles. We can use those two triangles if we want. There's other stuff going on here, like there's vertical angles here and vertical angles here. So there's a couple different, ways to go about this. But let's go ahead and talk about what we have already. I was talking about using these two sides or these two triangles, and it looks like it might be easier to use these two. So let's go from there. All right, so now what I can say is that these two triangles are congruent to each other, okay, because I have angle, side, right? Angle, side. We also, if we wanted to talk about the vertical angles here, which we could do angle, side, angle. It doesn't really matter. Either way, we know that this triangle is congruent to this triangle. Okay, so let's kind of write that out. Triangle EZT is congruent to triangle YZC. Okay, and we're going to do that by angle, side. Oh, shoot. We forgot to put in that line about the congruent. Sorry. Let's get rid of that for now. We talked about this. We just didn't write it out. Sorry. Step 3 is the alternate interior angles. So let's write that up. So angle TEZ, this guy, TEZ, is congruent to this guy. That's going to be CYZ. Okay, that's all int angles theorem. Okay, and by the same theorem here, we have angle ETZ, this one, congruent to YCZ. Okay, also alternate interior angles. Okay, again, you could talk about the vertical angles if you wanted to. You could also like put numbers in here if that's going to help you. Sometimes the letters can get a little confusing. But we marked it. We're talking about this angle congruent to this angle and this guy congruent to this guy. And it has to do with the parallel lines and the transversals. Okay. All right, so now step 4. Sorry, I kind of jumped the gun here. We know triangle EZT is congruent to triangle YZC. And that was angle, side. Okay, it's not the only way to do this proof, but that's kind of just the information that started stacking up for me. Again, you could talk about these vertical angles if you want. Okay, so we just showed that these two shaded triangles are congruent. Okay, well, if that's true, then we get all the other stuff as a bonus. So we already have the 3 angles, but that means this side has to be congruent to this side, and this side has to be congruent to this side, right? Because the corresponding parts of congruent triangles have to be congruent. Okay, so step 5, we basically got what we needed to. So we got, I'm just trying to get the order right. We got the YZ is congruent to EZ. Okay, and that's CPCTC again. All right, so as soon as we have 2 triangles congruent, then we get all the other information from those triangles. All 3 sides have 3 sides congruent on the other side, so I can mark these congruent, right? All 3 angles have a congruent angle on the other triangle. Okay, so we start by using one of the triangle congruence theorems or postulates, AAS, ASA, SSS, SAS. Okay, and we get the triangles congruent. Then we can use CPCTC to get any other piece that we're after. Okay, so one step longer, it's a little bit longer, it's 5 steps instead of 4, but, and this angle step was kind of the hardest, but that's kind of how you set that one up. All right, the next one is kind of similar, it's a similar shape, the given is a little bit different, but you can kind of use the same idea there. So that should help you get going. That's most of the ones that you need, and if you're getting stuck on those or kind of confused, then hopefully that helps. Okay, so finish it up and make sure you turn it in via Canvas, and the hard copy will go in your notebook. All right, thanks, and hope to see you soon in class.